we present a novel LiDAR sensor-agnostic multi-session SLAM approach, called Multi-Mapcher. We tackle the issue of multi-session SLAM with heterogeneous LiDAR sensors by proposing a sensor-agnostic approach that does not depend on LCD modules. In our investigation, we observed that existing loop closure detection-based multi-session SLAM approaches may not perform well when sessions are acquired by different type of LiDAR sensors. This performance gap is owing to the sensor characteristics, especially the field of view and data density. The geometrical differences in point clouds acquired from different types of LiDAR sensors across the sessions trigger the failure of loop closing detection modules in multi-session SLAM, which finally leads to a misalignment between sessions. To address these problems arising from different type of LiDAR sensors, we propose Multi-Mapcher, a novel sensor-agnostic multi-session SLAM approach. First, we conduct intra-session SLAM using existing frameworks, generating scans and optimized poses with intra-session odometry and loop constraints. Second, we perform map-to-map level registration by leveraging Outlier-Robust point cloud registration to estimate the initial relative pose between the query session and the central session's reference frames. Third, we also exploits Outlier-Robust registration for submap-to-submap registration to detect intersession loops by a radius search. It is followed by our truncated mean squared error-based false loop rejection, which efficiently prunes false loops. Without this truncation, the MSE between point clouds could exhibit abnormally high values, owing to field of view differences. Finally, we construct and optimize an anchor node-based pose graph to refine all the poses across the sessions. In our experiments, our Multi-Mapcher was quantitatively and qualitatively compared with state-of-the-art methods on the HeliPR dataset. Our Multi-Mapcher showed substantially better performance in different type of LiDAR sensors, achieving lower inter-session alignment error in MSS across all sequences. And we demonstrate that our Multi-Mapcher accurately aligns different type of LiDAR sensors sessions. And we demonstrate that our approach is even robust to partially overlapped scenarios on the KITTI dataset. Finally, we investigate the runtime of MSS approaches in the initial alignment process to demonstrate its speed and efficiency. Therefore, we conclude that our approach is not only robust to different type of LiDAR sensors, but also performs MSS quickly. Here are some demo videos. First demo is tested on Conrist 05 sequence on the HeliPR dataset. Query session is acquired by an audio LiDAR sensor, and central session is acquired by an OS-to-128 LiDAR sensor. Compared with our proposed method, LCD-based methods resulted in numerous false positive loop constraints, and the number of true positive loop constraints was significantly lower than our proposed method. Next demo is tested on Town 03 sequence on the HeliPR dataset. LiDAR sensors for each session are the same as in the previous demo. In this, similar to the previous demo, our proposed method shows better results. In particular, our approach still gives fewer false positives and many more true positive loop constraints than LCD-based methods. Thanks for watching. More results are in the paper.